When you start taking electrical engineering courses, there's a core set of courses. Everyone has to take every one of those courses. Once you've completed your core engineering, you can sign up for a capstone course, and everyone's required to do one, and essentially it ensures you have experience on a real engineering project. A capstone counts as a laboratory, so you're expected to perform 9 hours of work outside of class on this. I put in at least that much, everyone puts in at least that much, and it really helps. It's not like work that you have to do, it's work you want to do, because you're working with such a high-tech piece of equipment and so much really cool stuff. It's really something you want to do. This is our autonomous helicopter we're working on for our capstone project with the Rio Robo Lab. The helicopter's been disassembled, and the servos have all been rerouted through a board that's going to control whether or not the receiver it can be talked to just conventionally like you would a remote controlled helicopter, or whether this electronics box, which will contain all of the processing that's going to make this fly by itself. This helicopter will be capable of taking off and hovering to a distance of several meters and staying there and staying stable. Now, anyone who's ever flown an RC helicopter will tell you that's not an easy task. There are gyroscopes on here, accelerometers on here, and all of these give feedback to the control system about what exactly is happening to the vehicle in the air. We've taken a new approach to this project starting last semester. We've added a lot of capability to it, and once the programming is done, which is the real difficult work and all of the design work, it'll be easy to expand this into more and more as we find new sources of funding and new applications.
I'm a part of the Flying Aggies. We are a team of students that have proposed an experiment that will be performed in microgravity. And NASA at Johnson Space Center provides students with that opportunity to perform those experiments by flying them in an aircraft that performs parabolic maneuvers in order to generate that microgravity environment. The NASA microgravity program is basically a competition for students from universities all across the nation to compete to fly on the aircraft to be able to perform these experiments in microgravity. And basically what we're going to be doing is we have a mock-up satellite similar to this, and it's going to have a robotic arm and the satellite body. And one of the critical things we're trying to identify are how the inertial properties of the spacecraft changes as, say, the robotic arm deploys. So basically what happens is when these satellites couple, or these two spacecraft couple, their inertial properties are going to change. That means their center of mass are going to change, the overall mass of the system is going to change, and also the inertial properties of the system are going to change, which means it's going to react differently to different forces. And then it's critical for a spacecraft or the control system of a spacecraft to know these properties in order to accurately guide and maneuver while it's in orbit.
ASE, we do a lot of community service. We do fundraising to support the concrete and steel bridge teams. Each year we go to competition. We build a scale model of a bridge, and we go up there and they load 2,500 pounds of steel on it, and it can't deflect more than 2 inches, and no piece can be more than 3.5 feet long or weigh more than 20 pounds. This is a piece of the steel bridge from last year. Last year we had a truss bridge. What that means is we had 2 beams, 20 feet long, and a truss that came over. The reason for the truss was to reduce how much the beam deflected when it was loaded. When we construct it, no piece of the bridge could be more than 3.5 feet long and 6 inches in every direction. So what we actually did was we built a box and checked to make sure that this member would fit in the box. And also no member can weigh more than 20 pounds. The other team is Concrete Canoe. They actually build the canoe out of concrete.
This year there's 12 of us, 12 students, and what it consists is building a canoe out of concrete. Basically we make a mold out of foam. The next step in the process is putting press and seal on the canoe. That's gonna help, release the concrete from the foam. And it's basically just press and seal you use every day at home. And then after you put the whole thing of press and seal, fill it up, glue it down, and we put this trim around it, that goes all around it, that is gonna make a nice little shape. It's gonna give us points. It's gonna look all pretty. And after that, we just start placing the first layer of concrete. In between each layer, there's gonna be reinforcement on it. So there's gonna be the first layer of concrete, and then the second layer of concrete, and this is gonna stick in the middle. So it can hold my weight, and it won't break. It's a great team, and when we do stuff like this, it's always so much fun, because you get all the students' energy and going out there and keep doing it every day.